All right, this is section 1-2, the process of. And here's kind of our objectives, things we're going to try to cover in here. We're going to talk about the scientific method and be able to list some values for that. Know the difference between these terms, hypothesis, theory, scientific law. Talk about experimental controls and what are some of the components of that. And be able to understand the concept of a model and why we use those and some of the limitations that are involved in those. All right, so let's start off, kind of the early days of science, way back in BC. You have these three kind of famous philosophers from Greece, Socrates, Plato, Aristotle. And Aristotle is one who kind of did a lot with, thinking about science and things like that. He had very, very influential views, and most of those stuck around till late in the 1300s. Unfortunately, a lot of his opinions were wrong. And the reason is he never bothered to test any of those things out. He just figured that you could just logically think about everything, and that would be how you would figure it out. So he had simple ideas that you could easily have checked. Like he thought that because men were bigger than women, men would have more teeth than women. At no time did they ever bother to count and find out that men and women have the same number of teeth. Or he also thought that heavier objects would fall faster than lighter objects. And, that makes some common sense, but it's not real. It's not true if we neglect air resistance and things like that. So, kind of, somewhere around the 1300s, scientists or people then started using what was known as the scientific method, which is basically a way of experimentation that follows some logical steps to solve the problem, come up with some new answers. So let's talk about the steps. First of all, you need to know the problem, or what's the phenomenon that you're going to study. So step one, define the problem. Step two, gather and organize data. So you're going to make some observations. So you're going to look at, what's going on. Step three, suggest a possible solution or explanation, which we call a hypothesis. Then you're going to test that hypothesis. You're going to make some new observations. And if everything you did supports that hypothesis, you might accept it. You may do some more testing with that. If it doesn't agree with that, then you may need to start over, make a new hypothesis, and so on. Now, you use the scientific method, in just about everything that you do. So anytime that you're trying to figure something out, you're going through that process. This is nothing new. It's just a very, very, it's just an organized way. And this set of ideas for the scientific method, I've seen in a number of books. Sometimes it has 4, sometimes it's 5, sometimes 3. But it's these things just depending on how they divide them all up. Okay, so we've already talked about hypothesis. If we have hypothesis that has passed a lot of tests and it always kind of rings true, we may turn that idea into a theory. So a theory is one that takes all of these things and is, as far as we know, is true. Now we can't ever prove that, but it fits the data. Okay, so a theory is an explanation that summarizes your hypotheses, or maybe a number of hypotheses, and over time has been tested and has met that standard. And we've talked about a lot of things. You've heard of some theories, like there's the Big Bang theory or theory of relativity or theory of evolution. Those are all theories. Now, none of those are proven. We can't prove them. But what we know is that there is certain data that leads us to believe some of those things. A theory can also be a possible explanation for a law. Talking about a law, we're simply talking about a statement that summarizes the results that we've seen over and over. There's no exception. Things like the law of gravity, we know that every time you drop something, you let go, it's going to fall down. We understand that. And so that becomes a scientific law, more of a summary of what you see versus a theory which is trying to explain. And then to test those things, we would use an experiment. And we want, in science, we want to do controlled experiments, okay? And what that means is we're going to only change one thing. We're going to have two sets of things that we're experimenting with. One where we're going to change one thing about it. So maybe we're trying out a new fertilizer. So everything we do else is we do the same on the plants. We give them the same amount of light, water, everything else, except for this new fertilizer, and we see what the difference is. Now, when we do them in the classroom, these are usually already known. And your goal is just to try to get the same thing that people have done in the past. Maybe we'll get a chance to do some that are just completely, we don't know what we're going to get. And in that case, you want to make sure that you have a very controlled experiment where you're taking a sample, where your experimental sample is different, you're changing something, and then your control sample is exactly, nothing's changed on that. So the control sample is what we're going to use to compare. And then we're going to see, well, what's the difference between the one we had before and the one we had after we changed one thing. Don't change more than one thing, because then you don't know which of the variables made the difference. You always want to just change one at a time. And a lot of times in science, we use models because they're much more descriptive. We're a lot of times talking about things that are really small or really big, and so we need a way to kind of understand that a little bit, and the model is how we do that. It helps us to kind of enhance our understanding. And so a lot of times if we're talking about the atom, we might have a picture or a drawing of the atom, which is not a real atom. It's just a model that represents that. It's not perfect by any means. There's going to be some issues with it, because we can't do that exactly. Or if we're talking about the universe, we might have a model of the universe, but obviously it's not going to be represented exactly. But models make things a little easier to understand, and that's important in science. And that is the end of section number 2.